Thank you. Hello, everyone, again. Well, this work is one extension of the previous work that we presented in a previous conference. The idea is detect healthy and defective fruits, that case using apple and mangoes. In this new presentation, we propose the classifying healthy and defective fruits, but using another type of architecture, that is a multi-input architecture, and using CNN models. This work has been done in collaboration with Luis Chuquimarca and Professor Sergio Belastini. The content of our presentation has been divided in 5 sections. The first of them, motivation, previous work, a proposed approach, experimental results, and the conclusion at the final. On this slide, we discuss the motivation behind our research. We discuss the importance of classifying fruit correctly in post-harvest processes. For example, some of them is the quality inspection is done by specialized agents. This process is evaluated manually by a specialized person with experience and training in the subject. The fruit quality inspection involves assessing ripeness, deformation, and defect, and the higher quality leads to higher profit and the better markets. In addition, another important motivation of our research work is that the correct classification of fruit in post-harvest process has an impact on a market benefits on human health. For example, ensuring quality control of agricultural product has a benefit for human health and essential for food safety. Related with the previous work that we published in another conference, we work with defect detection using CNN models with real virtual image data set. In this work, different CNN models were evaluated in order to compare their performance, recognizing defect or healthy in apples and mangoes. For this work, 2 types of data sets were generated, one real images data set and one synthetic image data set. This type 2 of data set were used for the apple data set and for mangoes data set. Then the single 2 architectures were used in this previous work. Sorry, one architecture was using in this previous work, the single architecture. This was used to train it CNN models. In that case, we used Inception V3, Mobile Net V2, DenseNet 121, and BGG 16. In order to classify these 2 types of fruit, apple and mangoes, have healthy and with defect, we obtained, for example, for apples with mobile net 97.50%, for mangoes mobile net to 92.90% for mangoes. In this new proposal to change basically 2 things. One of them is we are changing the data set, because now we are going real image data set, and another type of data set is the silhouette images for detailed observation of defect. The other change is the use of multi-input architecture that receive pair of images. In that case, are real images, and the another one silhouette images that enhance the defect in the fruit. So our contribution can be summarized basically in 2 points. The first contribution is the dataset containing RGB images and silhouette images. The second contribution is the use of a multi-input architecture that use RGB images on one branch and their corresponding silhouette images on the another branch. The generation and the use of this multi-input architecture are described as follows. For the dataset generation, first of all, the real RGB images dataset from the previous work that we published in another conference was used. Then this real dataset was used in order to obtain a respective silhouette image dataset that was generated using SAM model. The idea with this new type of dataset, silhouette images, allow to see the details of the defect in the fruit. And this process was done for apples and for mangoes, like you can see. After the dataset has been generated for both apples and mangoes, these image data are used as input to training 2 types of CNN models in order to classify the apples and mangoes as healthy or defect. For this work, we are using MobileNet and BGG16 models for train and evaluate these 2 types of CNN models. That was done for apple, and that was done for the mangoes. In the experimental result showed that using silhouette images with multi-input architecture results in better accuracy than our previous work. In this case, the MobileNet achieved 100% classification accuracy for apples and 99.5% for mangoes, compared to 97.5% for apples and 92.9% for mangoes that were obtained in the previous work. This emphasizes the efficacy of different architecture in a previous valued insight for future research. Finally, the conclusion of this work is this new study demonstrated improved accuracy and performance over the previous work, enhancing the classification of healthy or defective fruit with a multi-input architecture using RGB and silhouette images dataset. And another conclusion is that the inclusion of a silhouette images dataset improved the performance of multi-input architecture. The MobileNet V2 multi-input model was identified as the best performing, achieving 100% for apples and 99% for mangoes. Finally, in the future, work should be implemented this model with binary segmentation to classify other type of fruit and improve the quality of the data set. In addition, it is recommended, for example, evaluate other type of architecture such as Siamese network. That's all. Thank you.